Hetti, Security Safari, Adventures in b0rkenLand. Go.
Well, good morning. I hope you have a good sleep, everyone. I didn't have, but, well. Let's start. Welcome to my lecture about Security Safari in b0rkenLand. First, clarification. This is not a talk about the Safari browser in macOS. It's not a talk about this. It's a talk about security fuck-ups in 2018 that happened already, and I just do a review and I do an introduction. So I do the security 101 with you. So, like, to clarify all the stuff like denial of service, command injection, CVSS, and so on. So not everyone is familiar with these terms. Let's start with CV. So CV is common vulnerabilities and exposures. It's industry standard, which is a naming convention for vulnerabilities and exposures. And only publicly known security vulns are there. It's like obvious. If you don't know there's like 0 day, like unknown exploit, then you will not have a CV for it. And that's like a sample on the bottom how it works. So it's CV with the year of the finding of the exploit or the bug, and then a number that got assigned to it. Then there is CVSS, so Common Vulnerability Scoring System. It's also a free and open source industry standard, and it's like a scoring system for the vulnerability from 0 to 10. It's based on formulas and depending on different metrics. So it tells you how critical the bug is. Like if it's like a 10, it's rather critical and probably maybe also easy to execute. If it's like a 5, it's not so problem. If it's like 0, then it's like, okay, maybe you don't care about it. So let's start with RCE. So RCE is remote code execution. So you execute on a remote target your own code programs. That's quite a common vulnerability. I checked out the statistics, and it's quite a lot of RCEs around there which are like mapped with CVs. The next common thing is command injection. So you inject own controlled commands into systems. For example, via some web interface, for commands. Like the classic one is like you have on your Wi-Fi router, you have your ping interface where you can ping some address, and you just then also inject some shell command, and it will also be executed if it's not like sanitized the input. And then you can just execute your arbitrary shell commands and pinging some address. Also very common is also auth bypass, so authentication bypass. So for example, you log in without credentials to some device, to some website, or only you know the username and you don't need the password because you just bypass it. Then there is DOS, so denial of service. It makes the system unavailable, so maybe temporarily because it crashes, or even you break it permanently and it don't even works anymore. So it could be both, depends on the bug and the system. Then like very important stuff is POC, so proof of concept. So normally if you find a bug, you like write a proof of concept for the people that you show them, well, it works, that the bug you can like execute your code and it's working. And normally some source code which you just run and then like execute it, like some Python script or some shell script, or even a compiled binary, depends on your proof of concept and how hard it is to exploit your bug. So there is one classic proof of concept for RC on Windows. It's just like popping the calculator. So you have like remote code execution on the Windows system, and then you just call calc.exe, and then the calculator pops up, and then you can show the people, well, I got code execution, and then you just pop the calculator, and that's like the proof of concept that you got code execution. Well, Next common thing is out there backdoors, like built-in bypass, built-in method for bypass authentication or encryption of a system. They're also quite common for this, and now I will start with the part of some known vulnerabilities I researched in 2018. Let's start with Cisco. So Cisco is a big network equipment vendor, and he has a long backdoor history. Like they found several backdoors in their devices. And one thing I saw is they are very creative about finding synonyms for backdoors. Like I have here 3 examples, like undocumented user account with privilege level 15. Then like undocumented static user credentials for a default administrator account. And also like undocumented test interface. Like the last thing is just some open port and you connect to it and you get like a root access and can do what you want on the router. Great stuff. So if you lost your password for admin account, go for it. Then yesterday I researched this funny stuff. That's some internet Wi-Fi router, and you get easy root access in 3 steps. Damn, I missed the stuff. I wanted to put in the password afterwards. Well, so you request to the website endpoint go form/telnet. It starts the telnet server on the router. Then there are you can choose freely from 3 existing default accounts on the device that are root accounts. So you can choose between user, root, and admin. And well, the password is 123/4. And yeah, log in and profit. You have root access on the Wi-Fi router. The thing is also, there was the CVE link I will put on the slides later online, and you can check all the CVE links of the problems. And there often even more information on the bottom, like links to write-ups and links to like other information pages. And at this write-up, they said they contacted the manufacturer of the router, no response. Then a second contact approach, no response. Third contact approach with, hey, people, here are CVEs, and please, would you do something? And we will do a public disclosure if you don't do anything. No response, and then they publicly disclosed this vulnerability to the internet. Well, you probably also heard of Meltdown Spectre. It was really big in the news, like in the beginning of the year. The thing about these vulnerabilities is that it leads to extraction of sensible data in the memory. And the problem is it's a design fault in a modern CPU architecture. I said it's a hardware bug. I mean, it's like used as a feature. It's called speculative execution. So your processor is like not only doing the normal calculation, but he also like speculatively calculates other values which we might need later. So he do it beforehand, and if you don't need it, they just throw it away. But you can exploit this, and with this you can like get sensible data out of the memory. There are software fixes available for this. Some are not so easy to do, like because they're like like micro patches for the CPU architecture, which got like applied on boot, and they need to be applied like every start of the computer. But normally your operating system does it for you on Windows, and it leads to loss in performance. I mean, if you're a normal user, you will not see that as a problem because maybe you will not see it. But if you're like some big company running like some servers with some calculations, you will really see it, and it might be a problem because you need to buy new hardware or extension hardware because you need the performance for your calculations. Another great RC was Electron RCE. So Electron is a framework for cross-platform apps. Electron is like running with, it's a Chromium browser. You can have like HTML, CSS, JavaScript running there, and you can do a lot of apps. So a lot of apps are done with Electron, like Signal desktop client, Wire desktop clients, like Skype client, and so on. And yeah, it's people like to use Electron because you can pretty easy bootstrap quite faster apps and have quite faster apps, and it's like easy to implement and cheap and fast instead of like implementing native apps. Yeah, the bug was you could like re-enable some node integration variable via XSS, so cross-site scripting. It's a tag in JavaScript, and that allowed execution of system commands on every platform. So it also got the CV ID, and there's also a nice write-up of this bug. So in the end, you needed like like a chain. You first needed to exploit via XSS, and then you could like do a remote code execution. So the next one will be interesting. So probably a lot of you people are also gaming, and you probably have Steam. And like I think some weeks ago, it got published. There was in the Steam client, there was a remote code execution existed for already 10 years in it. It got reported to the Steam team, and they patched this vulnerability after 8 hours after report. So we're quite fast to fix this. And malformed UDP packet was enough to trigger the exploit. I mean, you need to know what to do, and there was like a ROP chain to exploit, but still the whole thing was quite easy to do. There is an extensive write-up under the web page here. You can check it out. It's really interesting. And so you could have done potentially on 15 million devices remote code execution. So another great vulnerability is the Seagate personal cloud. So it's a media server for home use with like 2 hard disks in there. And it's running a Django application. And so for the exploit, you don't need to authenticate. So you just send to some URL endpoints some get parameters. And they're like passed unvalidated, unsanitized to the Python modules. And if you like don't validate and unsanitize your input, then that happens because that led to command injection, and you could like running system commands as root. So that's like the most important thing is like in programming that you like sanitize your code wherever your input, wherever the user can like put data in, because if you don't watch how that happens, that you get like command execution because of some unsanitized parameters. So the next one is one of my favorite. So HPI ILO4 Auth bypass plus RCE. It's ILO4 is a remote management console for servers of HP servers, and yeah, it was authentication bypass plus you could also like do a remote code execution. it was found by Airbus research team. They invested quite some time, so they told in their presentation they invested like 5 man-months for research for the exploit and for the bug. Like they checked out the firmware and the chip and everything. It's exploit from 2017, but it got like broad public knowledge in 2018 when they presented in a conference the research. And for this, I have also a GIF with the exploit. It's, well, you will see yourself. So he's doing a call request on the interface, and he got a 401 unauthorized. Well, then he just starts Python with print 29 times A. Well, then he adds a header to the connection. So connection. Then he copies the 29 A's into the header. And he got authenticated to the system and, well, has root access on the server management interface. And with that also he could like do remote code execution. And yeah, it's quite a hard vulnerability, and it's very dangerous. I mean, if you have a server out there that's normally public to the internet, the management console for people to management their servers, and with that you can like just hijack the servers and do the stuff you want. So there's also another great thing I found, that is this Netwave IP Camera. It's a denial of service. So the exploit is you just send a post request with a huge body size to this URL, and it just crashed the camera. So if you do it all the time, the camera don't work. There is a proof of concept on GitHub. You can check it out, and sometimes you just need as much as this, and that's done. So for this you don't need some special knowledge. You just start your browser, and then you just change in the development settings the request, and that's it. And then you crash the camera. Then if you have a BMW, they have a telematics control unit in the car, and for this there are BMW vehicles from 2012 to 2018. If they have the telematics control unit present, they are affected of the bug, and you could attack the cars remotely via cellular network. So they managed to gain control over the CAN bus with execution of arbitrary unauthorized diagnostic requests remotely. So you could like mess up with the CAN bus interface of the car remotely over a cellular network. Normally you don't want to do that because that could have some unwanted behavior while you're driving your car. I mean, there was also some good attack like some years ago with a I think it was a Toyota, where it owned it also via the cellular network, and they could like stop the car, speed it up, or even they could also disable the brake, so the person couldn't even brake with the car. So I have one last thing to present for you. It's not a software bug, it's a hardware bug. So there is this guy on Twitter, he's called Lockpicking Lawyer, and he gets like lockpicking, he's doing lockpicking and gets some locks and analyze them. And he got the lock from some Chinese vendor with a fingerprint reader. And it had a quite interesting detail, and also very interesting was the response of the Chinese manufacturer when they provided him the lock. So look at yourself. So they sent him this lock, and there is this great screw there with the red dot, and I mean the response is hilarious. I mean it's in a tweet. It states like, the companies that sent me the pictured fingerprint lock has provided the security code of the year. The lock is invincible to the people who do not have a screwdriver. I mean, okay, but probably the most of the people have a screwdriver or just can get it somewhere for fast. They open the lock and then it's open. So it's very secure. There was also some other lock, also some smart lock, where you could like just open the back of the lock, then unscrew some drives, and then the lock just fell apart. So that were the vulnerabilities that I researched in the last 2 days. And well, get some popcorn and take your time. So if you got curious in all this security through, so reading CVs is fun and interesting. So there are even a lot of more other CVs I researched. There was some command injection in some Minecraft installer via PHP command injection, like this, or like other RCEs, XSS, Auth bypasses. So there is the website cvdetails.com where you can just search for search for bugs and CVs. And there's a lot of extra information there that you can check out, like write-ups, white papers, and all the stuff. So take your time, check it out. It's really interesting. So do you have questions?
Questions? Come on, you can grow Hetti. He's on the stage.
Yeah, that's now your possibility to grill me in public. There is a organization where you apply the bugs and they assign you a CV. So there is some public organization which does that for you.
How long is the period to decide in public for the vendor to fix the bug himself before publishing it?
You mean how long it takes till the CV got published? I don't know it exactly, but normally they normally should also like contact the vendor if like they didn't get contacted or if they don't like answer. And I don't know the exact period, but in the end, if they like do responsible disclosure, they just contact the vendor multiple times, and if they don't like respond, they just release it on the public, and they got also CVs applied. So yeah, it's right. There not a lot of information. Maybe some just like in product X there is a authentication bypass where you can get root access, but nothing like specific what happens. It depends on the CV. On some CVs there's also like additional links or even links to proof of concepts. But there's a lot of CVs who just say, okay, in this product there is some bug and you can exploit it, but that's it.
The point with CVEs is that they're totally arbitrary, and a lot of bugs don't think that if something isn't on CVE that it doesn't exist. Like there are people who find bugs, find vulnerabilities, write up and exploit everything and just simply dump it in a text file somewhere, and they never request a CVE. Or
I mean, if you don't know the bug, so it will not be a CV. the Eternal Blue exploit from NSA. It was a 0-day. It got used by a lot of malware like WannaCry, but before it got public, no one know about it. So it has to be like reported that you get a CV. More questions? Yes.
As security research, if you found a bug, how is the way it's supposed to be to report it? So report first at the vendor, or create a CV, or what's it supposed to be?
So if I would found a bug, I would go and first report to the vendor and see how the vendor would like answer my report. And so in the next step, I would like apply for a CV, and I would probably go the way for responsible disclosure, like check it out if the vendor responds and give him like some time, like 1 or 2 months to respond and maybe to fix the bug. And if he's like doing with the router vendor and don't respond at all, I would just then like publish the code or the bug and say, well guys, here's the stuff, watch out, throw it away or whatever, because it's useless. But I think it all depends on a security researcher how he handles it. But if I would be the guy who find a bug, I would first report to the vendor and then see how the communication goes. Well then, if there are no more questions, thank you for listening to the talk. Yeah, stay safe and patch your systems, because unpatched systems can have remote code execution, and I don't think you want that. And if you wanna contact me, I have metrics. You can write me on Twitter, or you can also mail me at fsec@cyber.coffee or fsec18@cyber.coffee. And I have one last service announcement. So today in the evening we will play at the student dorm the Werewolf playing game. It's a fun social game we had yesterday at the night, a very fun round. I will also post the info in the Matrix chat. I think we will just meet at 8 o'clock at the student dorm restaurant, around 8 o'clock. So if you want to join, come, it's a really fun game. And yeah, thank you very much.